where
go
you
up to
use the
where you use the
vector one and two
vector
to create
1 and 2 to
data
Yes.
data
before the internet
Yeah.
started.
before
I
the
don't
internet.
know if you say anything afterwards.
I don't know if you say anything afterwards.
The vectors, and that will give uh, uh, what is it? A data. If you use the vector, you remember that the combined function means combine, but it's not operation. There's a difference between say vector one plus vector. When you add the vectors, but when you are using combined function, putting all of them, that's what I was saying. And if to look at this one here, if you wanted to build a matrix of you could use factors. You could. There are several ways of creating random numbers, and these are some of the. Maybe one day most of them will see how they work. So now, having known this, the ball is going back to you. The syntax I have here, just follow that particular syntax and create a matrix. Name it matrix one. Create what is your first matrix should be matrix one. Create a matrix of, let's say, 30 data points.
Sorry, I can't hear you. I only heard create a
Sorry,
matrix
I
of
can't hear
30
you. I only
data
had
points.
create a matrix of 30 data points.
Points of 6 rows, 5 columns. I want you to do a lot of typing. Uh, um, it makes you very flexible. So you must first of all know how to create the data before you then add this. So you can just do all at the same time. And if you were following what I have done here, you just need to pick one of them, and then that's all. That becomes your data. When you are done, alert me so that I will know.
Yeah, I'm done.
Yeah, I'm done.
Okay. So what did you print it? Did you see it?
Yeah,
Yeah,
I printed
I
it.
printed.
Okay.
I
Okay.
I
use the
use the
R
R
Okay.
data that we
data that
created,
we
which
created,
was
which
N of
was
30.
N of
So
30. So
I
Okay.
first
I
matrix,
first
then I brought
matrix,
data
then I brought
equals
data
to that
equals to that
variable n row
variable
6
Okay.
n row
column
6
5
n
that
column
rows
5 that rows
false.
False. Okay. All right. So then in that case, uh, so what about if I want you to create a matrix? I want you to create a matrix. How many are we? We were five, right? From the
Yeah.
beginning. Yeah. Myself, you, Eben, Mohammed, and Mahama. So we were five. I want you to create a matrix of the five of us, uh, and then each of us is occupying, let's say, uh, what is it? Each of us could be, yeah, what is it? Could appear, okay, five. Each of us will appear six times on that particular matrix. So the hint here is that you need to create a single vector of all of us, our names. Maybe let's do it together. So we start it this way. That will be our matrix. That will be your matrix 2. That will be my matrix 3 variable. Now I already have matrix 3. So I'm just going to say, I'm going to use the matrix function. If you don't do that, and then for the matrix function, for me, I can just write the entire code at once, but it's always confusing. So this is what I will do. I'm going to say names, uh, or name, or let me just let me put that place class, and then I'm just going to go there, use the vector to create all our names. So in inverted comma, I begin with mine. Then if I come out of bits, then I have yours. Then I'm just going to come out of it, and I have uh, Eben. Then let me have Mohammed and Mahama. So I have Mohammed, come out of it, and have let's say Mahama. So uh, there is a mistake somewhere. Okay, I mistakenly, okay, class. So now when I come to matrix, my data is going to be this particular vector. So what am I going to do? I'm going to repeat, there are five people there, so let me repeat those five people six times. That will give me 30. You get it? So I'm going to say repeat, all right? And what am I repeating? I'm repeating the class. That particular class here, I'm repeating it by how many times? Six times. I'm repeating it by six, I think so. Yeah, that will be all. Then I'm coming out of it to now say that I want the n row. Okay, I want my n row. Hey, what am I spelling? My n row to be equals to 6, and my n column will be equal to 5, and my by row is equal to, What's the matter? It has refused to come. I didn't put comma here. That's one thing I like about R. If you are conversant with it and you are typing, when you are making a mistake, the software will just prompt you ahead of time. Then you will see that something will not be right. Then it will hint you. Then false. So when I finished, I just ran it. And you notice that when I print now, we can see that all of us are there with our names. Each person's name appear 6 times on the matrix. Are you done too?
Object C names. Oh, I didn't run it.
Yeah, you need to run it.
Well, they say C name can be possible.
Come again. Have you run it and let's see? Has it worked?
I omitted comma between Mohammed and Muhammad.
Okay, then make that correction.
So I did then run. Yeah, so
Is it run now? Uh-huh.
yeah, it's run and the names are arranged
Okay.
vertically. The,
Mm-hmm.
like the names are arranged in rows and then in columns.
In columns. Then that's great.
Yeah.
So you should see that the column headers are 1, 2, 3, 4. The row headers are 1, 2, 3, 4, 5, 6. Right?
Yeah. Yeah.
So that's the difference between a matrix and then. So if you want to create a matrix of, let's say, characters, this is what you do. So if you are going to create it with numbers, you should already have the numbers built up somewhere, or you can build it yourself, or there's anything at all that you want, you can do with it. Now, let's say that the R norm that you use to build the matrix, you repeat that matrix but change the variables more. You can leave the number, the size number, the n to be 30, but change the standard deviation and then the mean, so that you can have different one there. I want us to do some little things with with it. So I come here. So I'm just going to say that's my matrix 4, and so I'm going to have my matrix function, which is there. So I'm just going to put that inside, and then have my I like copy and paste a lot to save time from. Then just run this, and that's straight up. I also have. Okay, so now when you run the R norm, did you see play T decimal point?
The second one you asked me.
When you run it, you will get the matrix, all right. But each of them will have a lot of data decimals.
Yes.
So you would like to reduce the decimals to, let's say, to if you want to reduce the decimals to let's say whole numbers or integers, come to the code, the first part of the code, and add round, and put it into bracket. If you want to run it and then go to the last part and close the bracket, another bracket there. So I run it again. The matrix will no longer have those things. Have you done that? You have only
Yeah.
integers.
Yeah.
Great. So now let's see if we can perform some little mathematical operations on the matrices. Or no, let me say, let's see if we can do some subsetting in matrices. So first of all, in matrices, if you are going to do subsetting, it's also the same as you write the name of the matrix. So just pick any of your matrix. Uh, what is it? Any of the matrix, like I just have matrix 4. Hello? Hello? Can you hear me?
Yeah, I can hear you. But the network is terrible.
Can you all hear me?
Yes, I can hear you. Eben.
Yep. So what about Paulina?
Yeah, I can hear you.
I thought you've gone to do second round of eating. What is it? I'm sorry.
I wish.
What happened was. Sorry. What happened there? My computer is misbehaving. Is overheating. So I bought a coolant. I always put it under. So as I was today, I didn't know that the coolant also had a small problem. So that's why it overheat and then just went off by itself. So I have to just open it right now.
Wow.
I have to open it and I noticed that the coolant has disconnected somewhere. So I open it and then I just reconnected it. And now it's working. So sorry about that. That's Nanado's economy. It's not my making. I should have bought a new laptop, but I'll manage like that until one day. What is it? I'll try and get a new laptop. Anyway, now let me share my screen. Eben, what is it? You are very late, and what is it? We've gone a little bit far, so I'll just run you through fast, so that I don't.
Okay.
I don't keep Paulina boring. I mean, can you all see my arrow? Is it clear?
Yeah.
Oh God. Obiani ho. What is it? They are pumping water and then they've left the water. What is it? Don't worry, guys. We'll go. Yeah, somebody has come. How can you be pumping water and be sleeping? I think we were here. Okay, so this is where we were. The last time we looked at data. Hey, somebody is doing pay. Who is that? Everybody is intact. Okay. We looked up to data.
Reshaping.
Yes. And so today we are looking at matrix, and then we are also looking at everything that I did under the matrix, everything is gone because the computer went off by itself without saving. Okay, so today we are looking at matrices, and then we are also looking at data arrays. So we've already explained that if you have to do a matrix, this is how it is. It's a very simple format. You just have the matrix function, which is already there. You just have to create your variable. By now, you all know how to create variables. Give it a name that you want. I always want to give it, a name that are relative. So I just say, okay, if I come here, I'm just going to say I have, I'll just say that's my matrix 1 or something like that. and then I just create a matrix by using the same way we use matrix function. And this way, when it comes, I was explaining earlier that any function you use in R, all the computer languages that I know, immediately you type the function, the syntax for how to input the data or the argument comes on top. And I just want to explain that so that you guys will get it quick and very fast. You see that matrix, you see that right after the function, and open bracket comes in, and you see data, which is equal to NA, means not available, because it's a syntax they are giving. It's an example. So it should be followed by the number of rows, the number of columns, by row, false, dimension names, and in that order. Now, when you have all this, what it simply means is that the first entry that you have to put in your matrix function is the data. What kind of data do you want to put them in columns and then in rows according to your specification? So you have to indicate that particular data set. You have to indicate how that data set is. And so I give an example around here. And so this is the data, which is equal to, let's say 1:25. Number of rows, you indicate number of columns. So the n row means number of rows. The n col means number of columns. And then by row, the by row simply means that, do you want, R is asking, do you want me to follow strictly the order you have given, or I can change? Then when you say false, it means R can decide to change the order. But if you say true, R will follow strictly the order that you have given. So in this case, I want number of rows 4, number of 5, number of columns 5. R will follow exactly that way. If I had mentioned true, R could change it and then make it maybe a different way. But this one, I think this is the only possible way that it could work. So when you do that, you just run quickly, you're going to have your matrix there. And then when you print it, you should have this in your console with each of them is coming as a vector, and that's where you have names, you have numbers like 1, 2, 3, and then being the header. So that's how we are able to create what the matrices. And matrix data is very important. We use matrix data to be able to determine correlation. If you want to do a correlational analysis, and you, Eben, if you are listening, you are working in the hospital. Supposing you wanted to measure the stress level of different professions. You see, you've picked some variables from police, from Ghana Armed Forces, from parliamentarians, students, the health workers of different departments. You want to do that. When you pick the data in the data frame, and then you can't use that one to be able to determine whether there's a relationship between whatever that you are measuring and their output. You won't be able to do that in a data frame. You have to change the data into a matrix, and that's why we are doing this. Now, if we have finished doing this matrix, I'm now going to look at how to be able to transform data frame into a matrix. You can get most of your data in the form of data frame. We can transform it into matrix, and it will work just perfectly. So that's how the matrix works here. But now let me give some few things here. For us to be able to understand or follow the matrix, let's all learn how to be able to create random numbers. One of the easiest way to create random numbers is, let's say, use sample. So the sample too, if you see that when I come there, the sample tells me that I need to have yep. So you see the syntax on top. I need to have X. The X is your data set. Remember, the X is the data set. The size is the sample size. So let's say I want to choose some 30 numbers from 100, 100 data variables. So I've just put that particular sample there, and then I have to tell sampling is a probability terminology. So I have to indicate whether it is by replacement or there's no replacement.
Hello, can someone hear me?
Yeah, even I can hear you.
Okay, So I can't hear him. Maybe he has gone off again.
Yeah, I think you might have issues with his
The
internet
PC.
or something. Yeah.
Okay. Should we create Paulina, should we create a platform so that we can be able to communicate? Because as
Yeah,
at yesterday, we were not able to have the meeting and we were not.
I thought you guys wouldn't
So I don't know, maybe at
were
the end
not
of
around
this.
because we tried doing it along the line. Something happened. I think there was no internet. No, sorry, I said internet. Lights. He had lights out at his end, so it was later in the evening.
Exactly at his end.
Yeah. Well, you can
Oh,
put
you said it was late and
around
continue, please. Yeah.
around 3 p.m. thereabouts. There was he said he had lights out at his end.
Yes, he
So
told me that.
yeah, around almost 4 before the lights came. So we tried
Oh,
having the class, and along the line something happened. Eh, I've just forgotten what happened yesterday.
I see.
Yeah, so we stopped. We were just about to start the matrix, and then his
PC went.
internet
Oh,
had issues. So when it
oh,
came,
okay.
it was almost 5, and he said he needed to cook, so we didn't do anything yesterday.
Oh, and that's fine. But um, so maybe at the end, this is the live stream. So at the end, then we share our contacts rather.
Yeah,
I'll talk to him so that he creates a platform for all of us.
that'll be fine.
Are you in Ghana?
No,
Oh, okay. Okay. That's okay. When we are off live, then we can talk.
sure.
All right. We have somebody else here.
I think it's only myself in here.
Well, I heard somebody mentioning my name on the background.
No, I'm actually holding my phone. So I saw a video and I pressed it, started making that's why I could play and so no one mentioned your name.
Oh, okay, okay. Right. Let me call him now. Maybe he has an issue at his end. Hello, Paulina.
Yeah, Evan.
Yeah, he says you'll be with us very soon.
Okay. Wanted to go and grab some few things. Maybe I'll go later.
Okay, okay. So welcome, Big Raj.
I think I ran out of data. What is these Vodafone people? They are thieves. I bought I bought data about 9 gig. So but the call is it Christmas 31 days something something. That's what I bought. Not only that data, it looks big, but it doesn't go anywhere. The thing is so volatile. So I had to quickly get to the. My house is very close to station. I just went to station to buy data. Sorry about that. Okay, so
It's
let
the whole
me.
system. It's the whole system.
What is it? Is what is it? It's not my fault. It's our grandpa. What is it? He's the cause of all this wahala. But tomorrow day I'll go to the office to make sure that I don't have these interruptions. Okay, so let me pull up the R. So this is where we were before we went off. So I beg you guys, in a case you are off, please quickly send me a message. Or those of you who may be on should just let me know that somebody is off. If not, I can see again. So I was saying that to be able to know how to do a data matrix, first of all, let's know how to create random data. And one of the ways is to make sure that we are creating a sample. So I'm creating a sample from 100, let's say population of 100, and I'm picking a sample of 30. And then because it is a probability function, we want to find out whether when we pick, we replace the person or we don't replace. So we just say false. And that's all. When we do that, we are able to print our 30 individuals as we have them here. So we can also come
Please
here.
take the replace again.
So I was saying that for us to be able to do matrix, we need to have the data portion before we can indicate the number of rows and columns, and then by row, either false or true. And then I want to take us through some few ways of creating random numbers or random data points. And I'm saying first of all, we can use sample. So we have a sample here, and we are sampling from a population of 100, and we are sampling just 30 people, and then the replacement. It means when we pick one person from the 100 people population, are we replacing the person or not? So when we say false, it means it's without replacement. And I'm saying that it's a probability term. So we can pick with replacement, we can pick without replacement.
Okay.
And please take note of this, because I'm actually going to use this to bring some kind of trick. The population, we can actually have a population of 6 and then say pick 30. Do you agree?
No.
Anybody? We can have a population of 6 and still be able to pick 30 people from there. We only need to do one thing.
Okay, so replacement.
That's exactly. We change the replacement to true. So it can pick 6 as many times as we want. Okay? So if I come here, if I run it, then I'm going to have this. So let's try that and see. Population of 10. I want to pick 30 people from there. Let's run that. They are saying that there's an error. What is it? That there's a large there's a large variable. So let's change this to true and see what will happen. And that works properly. You see the difference. So let's assume that I was saying that I wanted somebody to. Another way is to repeat. Let's say I want to just repeat one single number as many times as possible. I could actually do this. So let's say I want to repeat 6. So instead of me using the repeat function like this is also the repeat function. I could actually just use sampling and sample the same thing more than 100 times. It's the same thing as repeat. So another function that we can use here is by, let's say that, okay, I'm going to repeat a particular function. So, but with the repeat, I can also create a vector within. So I just use the C and come inside and say that, okay, I want 1 is to, 1 is to 7, or no, to 6. And I want to repeat that how many times? I want to repeat that, let's say, 5 times. So I can also print that out and you can see that it has been printed. So any of them, that's how we are able to create random numbers. We can use something we call normal distribution, R-norm, like this. The R-norm, you can see the syntax on top. And I was saying in R all the time. When you see that you have a function, the syntax is always on top. Look at how the syntax is. So n means that the number of items you are looking for. So let's say I'm looking for 30 items, and then I have to tell the mean and then the standard deviation. So it will print those items for me. If I say the mean like this is, let's say the mean is equal to 4, or let's say the mean is equals to this. Some of you should turn off your microphones so that the QQ will come out. And then a standard deviation of, let's say, if I put a standard deviation of, let's say, 3, right? So I can also run that, and that's going to give me a whole lot of things here. It's going to give me, some of them are negative, some of them are, some are less than that. So these are the various ways you can use also. You can combine any of them here and you will still be able to create your random numbers. But today our focus is on matrices. So what I want you guys to do right now is, let's say we want to create 3 different matrices. So we have our matrix 1. I have already created quite a number of the matrices. And then some of them are here. But they vanished. I don't know what happened. Don't know whether they are still around. So let me say this. Let me run this matrix and see. Yeah, it is still there. It's hiding somewhere. I'll find it. So let's say we want to create some matrices. I think all of us, let's begin and create 1. Let's say we have our matrix 1. I've created my matrix 1. So I have my matrix 1. So let's go, and then we say that we use the matrix function. So when you're using the matrix function, you can actually enter inside and then give your data. So that your data you are going to give, you can now use any of the random way of creating the data, and then that will form the data part of the matrix syntax. And then before you now bring your n row and then your n column, and then by row or by column. So if we understand this, let's go inside and then use the sample. This is what we have on top here, the sample. And then now we enter inside and say the first part is the data. So whatever we are going to do, until we are able to put comma somewhere, R will see everything as the data component. So we are going to create the data component here. So we say we are sampling we are going to use a sample, and you see that automatically this opens and small bracket will come. We are sampling from what population? From a population of, let's say, 50, and then we are just picking the size. We are just picking 30 people from there, and we are saying that replacement is equal to let's say false. Yep. Yeah. And then we have finished like that. So it means we have gotten our data. So we now bring comma there and now indicate how many rows do we want in that our matrix. Then we indicate, maybe we want 6 rows. How many columns do we need? So we come with our end call, put the equal sign there, and say we want 5 different columns. And do we want R to follow this syntax? We could just say this F and then run. Everything will run. There is something I was telling Paulina before you came. There's something we call hard coding, and then the best practice. You see, the last point where I put F, Aaron knows that I am saying that replacement is F, is false. That's hard coding. If not, I should have just written the replacement itself. But when you are fast, sometimes you don't, some of these things, they just go off. You just know that I'm supposed to put 6 here. So whatever is following is this, whatever is following is that. When we get to data visualization, I'm using ggplot. You will see how to be able to shorten your code. You can write a long one, you can shorten it as well. So, but this is how the whole thing is. So when we run, you see that it runs properly. We can come and print this, and then you see that it has been printed properly. So I want you people to create, gentlemen and lady, create just additional 2 matrices and see whether if they will work. And if they all run, then we go ahead and do something with the matrices. Let's do that as quickly as possible. So you can use either the sampling, you can use the repeats, you can use the R norm. There are several ways through which you can you can create your data. What the variables. There are quite a number of ways. Let me see. I hope everybody is online. Mohammed was off. Let me add him quickly.
Yeah, hello.
Yeah.
Can you hear me now?
I can hear you.
I
Yes,
didn't
yes.
realize I was asking.
Yeah, I just added you.
I think I joined late. So I'm finding it very difficult
To pick up.
Yes. I think
So
you've added some repetition and repeat and all those things.
Yes. Yeah. I was saying that. Yeah, I was saying that line 103 is the matrix, how to be able to create a matrix. But I'm saying that to create a matrix, you sometimes have to have your data already or your population already. So you can sample from that population. It's just a way of like creating random numbers.
Oh, okay.
So to create a random numbers, you can use a function called sampling. So you just say sample. Then when you come inside, you have the 100 is the population, and you are sampling only 30 people from that population, and you are saying that when you pick one person from the when you randomly pick one person, you don't replace the person. So that's false. So replacement false is the ordinary probability terminologies we are using. You see, and I was also saying that you could also sample from a small population and then with a bigger, but when you are doing that, you should make sure that your replacement is true. Because if I'm sampling 30 people or 30 data point from 10 population size, it means some of them I have to sample them more than once to be able to get 30. So you can't do replacement equals to false. When you do that, it won't work. And I was saying that you can also use repeat. So if I'm using repeat, I have some numbers here from 1 up to 6. I want to repeat those numbers 1 to 6 5 times. So it's like 6 times 5, that will give you 30. It's also the same 30 data points. So I was saying that you can do a lot of combination to be able to come out with whatever that you want to do. And so if you wanted to make this repeat completely random, you could actually add a mathematical figure here or a mathematical formula here. What is it? And then you will see have your random figures created. Another way is to use normal distribution. The normal distribution will tell you that the first number is the size of the samples you are looking for. But you need to give a mean and a standard deviation. And when you do that, automatically it will print the data points using the mean and the standard deviation, and then print 30 data points for you. And there are various ways through which we create random numbers. As you can see, if you run that, you are going to get this 5 point something, 7 point something, all those points and whatsoever. If you want to make sure that, so now I came to the matrix, and I'm saying now I have some matrix here. So I use the matrix function. The matrix function says that the first thing you need to do is you must have your data. So which part will form the data? So from the sample all the way up to this place, up to F, is the data part. Because you are using the sampling, you just want to pick 30 people to form the data. And then you want to, the structure of that data is a matrix. So there must be number of rows, number of columns, and then the F will tell you that do you want to follow the syntax or you want to have your own syntax. If I say false, it means that please follow my syntax. And that's what it is. So I'm saying that you guys use the same formula or the same idea, and then also create your own matrix, 3 of them, of any variables you want, of the same size. So yeah, go ahead.
Doesn't mean with this you should have data set somewhere because you are sampling somewhere
No, you are just I just put the sample there, 50. I just put the no, but don't worry about whether you have the data setting somewhere. Yes,
Okay.
you could have the data setting somewhere. Let's say you have the data point already, maybe in an Excel form, in SPSS or whatsoever. What we would have done is to go and import the data here and come and give the data a name. So now when we want to form a matrix from that particular data, then we will say matrix, and then in the bracket we will mention the name of that particular data, because we have already imported it and it's now part of the R string. All right.
Yes.
So let me give you an example. Let me do an example for you to see. There is a data set in R called empty cars, or they're just called cars. So I could just say I have a data, and then they are called cars. Okay. So let me run this data. Yeah, the data is there, but it will not be it won't be printed. So now let's assume that I want to form a matrix of that particular data. What I need to know first, I need to know the dimension. I need to know the dimension of the data, the dimension of the cars. So if I run it, there are 50 of them. It's in the form of a data frame. So 50 rows, 2 columns. But let's assume that I wanted it to be a matrix. So what I will just do, I'll say my matrix 2. Just give it some variable name, and I'm just going to do this and say as dot matrix, and then I'm going to put into bracket cars, then run this. So I have converted it from a data frame into matrix. So now let me print that matrix and you see. Now have you seen it? But the reason why I have converted it into matrix and you are not seeing the matrix like this, because I just left it the way it was. So now, this particular matrix here, let me say that it is. Wait, what is it? Let me leave it like this, and then I'll do something else, and then you see, you see it quite clear. So let's say I have, so I have the matrix function like this. So I enter the data part. I'm going to use the cars. So I'm going to say so data, the data part. So I'm going to come here and say cars, and then I have finished with the data part. Then I have my n row. Then that should give me, because there are 50 of them, so the row should be 10. Then the column should be 5, right? So n call is equals to 5, and by row should be equals to false. So now let me go and print the matrix, and you see. So have you seen how it has? Are you watching?
Yes, I am.
Yes. So in that case, let's assume that this cars, that's external data set somewhere. So when it comes and you want to make it into a matrix, that's what you do. You just follow the same syntax, but where you are supposed to put the data, you put the name of that particular data set called cars. Then you now indicate your n rows, your n column, and by row. You say print it. And that's how it is. So you see that we have printed it. What is it? It is fine here. But because the data was not designed for matrix, you can see that it doesn't really make sense. Numeric this, numeric this, numeric this. Yeah. So all the data sets, they are always designed with specific, because this one is actually cylinder head, engine, and whatsoever, and so it's just 2 data points, variables that you are watching. So that's what I want you guys to do. But because now I don't have external data somewhere, that's why I want you to create your own data set and use that to create the matrix, and then we can now work with the matrices and then see how to be able to perform or go about matrices.
Okay.
Yeah. So when you get stuck anywhere, just let me know. We'll just fix it out. What is it, Paulina, and then Eben? How far?
Yeah. Yes. I've been able to create something.
Have you finished creating?
Yes. I've been able to create something. Okay,
you should be able to create all.
Okay, but along the line, I realized that for the matrices, there's the number of. Okay, so there's an error that I got. They say data length differs from size of matrix.
Thank you. I knew very well that somebody will get that problem. That's why I was just quiet. I didn't want to mention it. When you give a data point, your data point are, let's say, 30. The number of rows and the number of columns should be a multiple of 30. Check that and see. If your data points,
say it again, please.
I'm saying if your data points are 20 or 30 or 40, the number of rows and the number of columns, when you multiply, it should be equal to that number. So you can't have a data points of, let's say, 30. And your rows and columns are not multiple of that 30. That's where the problem is. So check that and make sure that they are multiples.
Yeah.
When you run it to run properly.
Yeah, it makes sense now. Yeah, it makes sense now.
Yeah, great.
Okay,
Paulina.
so I've been able to create. Okay, so sorry, let Paulina go on.
One.
Sorry, let Paulina go on.
Paulina, how far?
I'm just
Yes,
Waiting. You know,
waiting. You know,
if
Okay.
you said earlier, I have
Okay.
light matrices
light
now.
mattresses.
Okay. But what I would have wished that you still create, you still, recreate the same thing all over again. I keep saying what one interesting thing about data science is when you are typing with your fingers, you get so used to the way to be able to, you become so flexible with it, and that's why I always want the typing. Even if you know the thing already, just type it again. Just type it.
Okay.
Okay.
Yeah.
So okay, I've done
So, okay, I've
something.
done something.
Okay.
My first
My
matrix.
first metric.
Uh
Should
huh.
I show it or I should explain
Should I
it?
show it or I should explain it?
Just yeah, you just explain it.
Okay. So my first
Okay.
matrix
So my first metric
I created
I created
um, with the data
with
was 1
the
to
data
25.
Points.
was 1 to 25.
Okay.
The number of row is 5. The number of column is 5, and then my by row is
The number
false.
of row is 5. The number of
Okay.
column is
Five.
5, and then my by row is false.
So it means that's great. Now the rest of the matrices you are going to create, make sure that they are also of the same number of rows, same number of columns, because we are going somewhere, and I want all of us to get to that point. So create additional two or three,
Oh, okay.
no, just two
Oh, okay.
more matrix of the same data point, 25, and then the same columns. But you could now
Okay.
use different.
Okay.
You could use the R norm to create the data parts. So the data part, you just use the R norm. R norm, maybe 30, mean 8, maybe standard deviation of 4, and that's something like that. I know you are going to get a lot of decimal points. You can use round function to take off all the decimals. They are not. I
Okay.
hope.
So
Okay.
my
So my
matrix,
matrix,
my second
my
matrix, what
second
I
matrix,
actually did
what I
was
actually
that
did was
the
that
data
the
points
data
was
point was
sample,
sample,
Okay.
but my number of
but
row
my
and
number of
number of
row and number
column
of
was
column was
2 and
2
5.
and 5.
So
So
I
it
should change it
means
So
to
I should
five
change
five,
it to
right?
5 5, right?
if it's 2 and 5, that's 20, right?
2 and 5.
2 and
That's
5.
10.
That's
Yeah,
10.
that's
That will
10.
be 10.
That will be 10.
No, no, go and change the population size to no, sorry, go and change the sample size to 25 and change the number of rows and columns to 5. Let them be uniform so that we can. But maybe Paulina could have different size, maybe 30, and then
Yeah,
Ahmed too could also have different. Yeah.
I
So that
have
one there, it
30.
doesn't matter.
I have 30.
30, 30, 30 is in order. All right. So now when we have this, um, Ahmed, have you done one? Let me see. His network can easily
Yeah,
disappoint
I've
him.
done
I've
two.
done
I'm
2.
on the
All
third
right.
I'm on
one.
the third one.
Okay. Yeah. Then we are almost there because we need to perform some few things right now on the matrices as fast as possible. What is it today? Because my network has my system has disappointed me several times. I'm just rushing things, but I just blame all these things on Nanado. He's the cause. He's, uh,
Am I in trouble?
Amazing trouble.
there's nobody to blame now. He's the one I'll blame. Everybody done?
I'm done.
I'm done.
Great. Now this is a subheading. So we want to look at, so just do hashtag subsetting in matrix. No, don't do that one. Do naming matrix. Naming the rows and columns of matrices. So we look at how to do that. You see that all of you created a matrix of the number of rows and the number of columns. If your number of rows are 6 and you are going to create row names, there should be 6 names. If the columns are 5, column names should be 5 names. Are we all there?
Yeah.
Great. So now let's go. Now we are going to create vectors of names. So we can have, let's say, vector 1. Just create any vector. Let's go this one. Let's do it together. I just have vector 1, or why not just call it row names? Row names, and then that's the name of the variable. And then what are we going to give? We are going to use vector sign to create, because it's actually a vector we are going to create. So we come here and say, let's use our own names. It's way better like that. So my own name, you can also have your columns, and there are more than the number of us who are here. You can add other people's names. It doesn't really matter. So use a vector to create names of people. By now, you know how to do that. You use the combine function C, and then you open and close your bracket. You have double quote. You write the person's name, they come out, comma, double quote again, in that order. So I have, then I will just come out and say then I'm just I want because I want to be realistic. What is this gentleman? I want him that I don't like people who come and say I'm interested. The following day you are not interested. In the night you'll be calling me and say, what did you do today? So I have created my row names. Then, because I have how many rows? I have about 6 rows, so I need to add one more name. 2, 3, 4, 5. So I have 6 rows. So the last name should be Konla. That's my grandfather's name. So I have my column names. The same vector. Because the column names maybe the columns could be variables, like let's say age, let's say height, don't worry about any spelling, weight, sorry, then I could have what again, salary. I will just have 1, 2, 3, 4, then the last one allowance. Okay, so, and now the last one should be matrix name. The matrix name, that one is also relative. It's relative. For me, I want to create, okay, you don't even need that one for now. When we go to arrays, then that's where you need it. But you could just create it and it will be just lying down somewhere. We'll use it later. So the matrix names, we can just say, depending on the number of matrices that you want to create, I want to create 4. So I'm just going to say, and do this, and I'll say department 1. So I just have department 1. When you come out of bits, I have department 2. I think I have a little problem. Yep. Then I have department 3. And then my last one is department 4. Great. So I just want to do this, and I'll just run. All of them, they run quickly. Are we all there?
Yes. Yeah. Yes. Yeah.
Great. So now if you have finished, then it's not time to, if you have finished, then we can now name the matrices that we have already created. So don't worry yourself about the matrices. We are going to copy the matrices that we have already created. I've created quite a number of them, and I want to give one of them, just copy one of the matrices, the entire code. Right? So I'm going to copy one of my matrix here, the entire code. Just bring it down to where you've created the names of. It doesn't really matter wherever you put it. So I'm just going to put it there. And then this is what I'm going to do. Right after the force, I am going to create a list. Or there's something we call dimension names. Dimension names. So you just say dim names. It should come with equal sign. And you use a list function. The list function. You see the list function will come there. Now, indicates inside the list. Inside the list. The first one, when you were creating the matrix, you brought n row, number of rows. So the vectors we have created now, the row names, that should come first in the list. So you write there, row names. It should even come, comma, followed by column names. So you have call name, call num. My friend, where are you? Call name. Yeah, that's how I named mine. Like this, and then that's all. When I do that, if I run it, now the matrix is now going to have row names and column names by those vectors that you have created. So now let me print the matrix, and you see, if I print mine, you see that it's now having my name, somebody's name, another person's name, and then our age, height, weight, salary, and then whatsoever. Very beautiful. If you are getting stuck somewhere, let me know. If you are watching my screen and you are seeing that when you are writing the code and the code is too long, you can always enter. But let me give you the trick. If you enter without any exclamation mark or mathematical operation, it will come to a new line. I will assume that you are coming to start a new code. But if it is a continuous code, you always bend the code at where you end exclamation mark. Let's say you're writing the code. When you get to comma, after the comma, click enter. It won't come to the new line. It will come and be hanging somewhere, like the way mine is hanging. It tells you that no, the code is not complete. You are continuing. So you don't enter without, we always enter right after exclamation mark or after mathematical operation. And that's how it is. When you also enter and you don't get it, come again.
I didn't get that.
I was saying that when you are writing the code, it can extremely be long. So if you want to cut the code into short, always make sure that you enter the code, you bend the code, let's say right after comma. For instance, my first one, matrix into bracket, I finished the sample. The data part, I put comma, so I put enter. So when if you do enter on your keyboard, it will come and start new line. But without the comma, when you enter, I will assume that you are starting a new line. So it will come and start a new line. And it means there will be two codes, not one. That's what we do.
Thank you.
Okay. So who has had his matrix names and columns named?
I've done that.
Okay. Then that's great. Let me wait for. Let me wait for the rest, and then and see. If you have any difficulty, here is not. We are not in a. We are in a discussion, so we are just doing it together. What Eben and then Mohammed, are you finding it difficult?
No, not at all. I'm just about to print.
Are you done?
I just want to.
Okay.
Yes, I'm done.
Okay. All right, then that's beautiful. Eben.
I'm on it, please.
All right. What is it? Be on it. So when we finish, we're going to look at, if all of you finished, the next thing we are going to look at will be subsetting matrices. I've already told you guys that the reason for matrices is for correlational analysis. If we don't know how to do matrix, trust me, you can't do any serious correlational analysis and be able to. And correlational analysis, all the thing we are doing, we will end up trying to build models. Data science is about building models. And we are going to build a model. That's when you realize that when you have so much data points that you have to deal with, that's where you will see how important matrix is. Because we have to really know what are the dependent variables having effect on the independent variables. So we have to measure each of them before we can come and completely say that, well, we've noticed that this is the reason why students are not performing in class. And then we can, all of us can just pick some data sets from our families and we just bring it here, all of us, we'll analyze it together. And you will see how we are going to use matrix and generate very beautiful plots. Self-explanatory plots. Very beautiful. I like matrices a lot, to be frank. Even though we haven't reached where I like in R. I like conditional statement in R. We'll get there. You just write condition and then you don't wait. The thing will just be looping and picking the variables one by one. Okay, the condition is not met, you skip. It has met, you jump. It isn't. That side is very interesting. Are we all done? Is it printed well?
Yes.
Can we go ahead?
Yes.
Great.
No,
Eben.
no, please. love with
No,
amen,
please.
please.
With love with amen, please.
Okay. Why are you locked up? Let's find you.
I'm at dimensions. When I
I'm
got
at
the
dimensions.
Dimension
When
names.
I got the
yeah
Uh-huh.
dimension names, yes. So I've
yeah
typed
dimension
list,
names,
but
yes.
the
Yeah.
options
So
I'm
the
I've
having
dimension.
typed
okay,
list,
okay,
but the options I'm having okay.
okay, I've gotten it now.
Okay, I've gotten it now.
Exactly.
Okay, I'm okay now.
Okay, I'm okay now.
Did it work?
Yes, please.
Yes, please.
Okay. Now, all of you, if it works, now I want to give you one example, and then you will now do the rest of the job. Now we are going to do subsetting. So your subheading is subsetting matrices. Quick, 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 quick. Subsetting matrices. So this is what we're going to do. In matrix, when you are going to subset, it's not like a data frame. Data frame, you can use dollar sign, you can use attached, and then you can use square bracket. In matrices, you use only square bracket. That's all. So you bring the name of the matrix. In my case, I have matrix 1 like this, and then you simply bring your square bracket. Then the rest is now the same as the data frame. The left side is your rows, the right side is your columns. So, and just like the way we did for the data frame, if you know how to be able to pick your rows and your columns, what is it in data frame is the same thing here. So if I do this 1 and I come and do this 2, it means I am printing just one variable. So that's 35. Subsetting and reshaping. Reshaping matrices. So that's it. All right. So you can actually do this. You can subset anyhow. You can use vectors and whatsoever. So what about if you want to print all the matrices at the same time? You use list function. So you say lists. The list takes all type of. So you just mention the names of the matrices. So in my case, I have matrix. I have quite a number of them. I'll just no. This one is not existing. So I have this comma. I have another matrix that may be 2 or this one. Then I have another matrix like this. So when you use the list function, it will print all the matrices at the same time. So you can see that I've printed about 4 different matrices. Now I asked you to create more than one different matrix. Now we have named the matrix. We know how to name matrices. If you understand, you can. Okay, the other 2 matrices that are left that you have. Let's do this over there and you see something. We want to combine one matrix to the other. We want to combine 2 of the matrices. That's why I was telling you that they should have the same row, the same columns. So just pick 2 of your matrices, and this is what you're going to do. And we're going to use the C bind. C bind means column bind. Then you bring the first matrix name, let's say main matrix 1, comma, and then the second one that you are combining. So let's say I have matrix, this particular matrix. So if I'm combining them, I am combining them by columns. So it means the number of columns are going to increase from 5 to 10. So if I do that and I run it, they're saying that I have number of rows of matrices must match. It means that one of my matrices, the number of rows are not the same. Great. So let me check which one of them. I'm going to check this, run it, and see.
This one has
Number of
6.
rows are. Come again. Okay, that's 6. Let me run this one and see. Oh, that's 5. That's the reason. That's the reason. So it means when the number of rows are not equal, you cannot use C bind. But you can use R bind. That one, there's no problem. So if I change the C to R bind, because I am binding rows. So that one, it depends on the number. If the number of columns are the same, that works. So you can see that that one works properly. I have bind the two of them. The first part, they didn't have names. The last part, they have names. So I have joined the two of them. So you can use R bind and C bind to combine them. But when you're using C bind, if you are using the C bind, column bind, it means that your number of rows are the same. So let's assume that now I want to change and see whether it's like I have other matrices whose okay, let me check for 2 and see. Yeah, that one too, the number of rows are not the same. What is it? They are not the same. Okay, I could just use the same matrix twice just to demonstrate. So I'm going to take one of the so let's say that's one of the matrix. I want to combine the other matrix. Is the same thing. I want to combine these two matrices together. So you can see that I've combined the two of them, and then they are now in one. I think I should rather use the one here. I could also use that one. I'm just combining the two of them. So you see that now the columns are now 10 instead of. Now, what about if I didn't want to combine all of them, but the second one I just needed to combine just the only first two columns. I just say, you just bring your small curly bracket, then use your comma to separate rows and columns. Go to the column side and do 1:2. It means you are just picking only two columns from that particular matrix and adding it to the other matrix, to the first matrix. And then that way, when you run it, you will see that, yeah, we've added 2 to 5, and now there are 7 columns. The same way we can do for rows. Then if we are adding columns that are not, if we are binding columns that are not in sequential order, we can just use a vector. We can just create a vector and do that. Let's say we were here, this side, the columns are not in series. They are not in series. So you just use a vector sign, then insert, and then maybe you want column 1, you want column 3, and you want column 5. So column 4 and 5, column 2 and 4 will not be there. In fact, you can actually write a mathematical formula or algorithm to select odd numbers, the odd columns, but that's advanced. We'll get there. So when you do this, it will still it will run properly and print it. So you can see that we've added the 3 columns, and then now we have 8. The same way, all that we have here, we could actually just copy that and then just come and paste there and change the C to R. In that case, we are not doing row bind. We are doing row bind. So I can actually bind the first two rows to, and then, so it means the number of columns are not the same. How? It's the same matrix I'm using, so why are they saying that? Let me find out where this mistake is coming from. Row bind, so let me come here and see.
Could it be that
the
the 2 and 4 columns that you've taken out is not matching with the first matrix?
Well, that could be a possibility, but this is weird, man. I've not actually taken them out. I just decided to just print it. I didn't even assign it to a variable, so I expect them to be there. But all the same, let me see. I really don't. Or maybe just a minute. So I'm going to have matrix 1, comma, then the same matrix 1, okay, let me see. I don't know where the problem is. So let me quickly see. Okay, so let me say I have my R bind here. So let me look for the matrix that I have rows and columns. No? This particular matrix here, MXTT1. Okay. So MXTT1. Right. So I want to bind their rows, and so MXTT1. Yep. You see that works properly. I think the reason why the first one is not working is that it's possible that I have a hidden matrix with the same name that doesn't have the same number of rows, that doesn't have the same number of columns. That's why we're having that mistake. There is a hidden matrix that is not displayed but has been committed into the memory of R. So when I type, it picks that particular one. So you see that now if I have, that's for the row bind. So if I actually wanted to bind, let's say if I wanted to just pick part of it, then it's the matter of just some few. If I wanted to use some, I saw where the problem was coming from. Yeah, but it's okay. So I have row 1 up to row, because the first one I only just changed the CC here. I think let me explain it so that it is part of the learning process. The first one that I did and it was not running. Remember, I copied this once here. I copied it here, and then when I came, I just pasted it and I changed the CC to R. But But you see that when I get to this place where I'm supposed to select the rows, I actually selected the column aspect. Are you guys there?
Yeah.
Yeah. So this 1:2 was supposed to be on the left side of the. It was supposed to be like this. 1:2, and then take
The
this
columns
side,
out.
the column side out. The same way here, I was supposed to just take that out, come and put it around here, and that way when you run it will work. Yeah, you see that it works properly. And then this one, argument 4 is empty. Where's argument 4? Argument 4. Yeah, because here, because the first matrix doesn't have. Here I am trying to join the rows of column, the rows of 1 up to 3. But what about 4 and then and then 5? So R will not accept that. So I think that's where the problem is coming from. Yeah, that's why this one is not working. Sorry, it's rather the top one here. That's where it wasn't working. So if you are binding, I am
Please, I don't
binding.
get that one.
I don't get that one.
I'm saying that I am binding this particular matrix, the rows here, row 1, row 3, and then row 5 to the first matrix here, matrix 1 here.
Yeah.
So around, and they are saying that argument 4 is empty.
2 is also
Two is
empty.
also empty. Oh.
Yeah, 2 is also empty. Wait. Okay. Okay. Now let me just clean the whole thing and then do it all over again. So this is where it was. Okay. So if I bind it all ordinarily, it will bind. But I'm not going to bind all. I'm going to bind some few rows. So I'm leaving this and I'll go to this side. So come here and say I want 1, 2, and then 3. Okay. Now let me run it and see. Yeah, now it works properly. There was a comma somewhere hiding. You see that one, it works properly.
There was a comma.
Come again.
You heard it.
Do you get it? Come again.
You had a comma somewhere.
Yes. Yeah. There was a comma somewhere. It's like it was this comma over here. Okay, so now we can use this to just play around, and then we are able to do whatever we want. We can apply mathematical operations on all these things. Now, let me quickly, in the next 10 minutes, do data array, and then we're out of here. The reason why I spend time on matrix is that data array and matrix are not different. They just that you just add something somewhere, and that's all of it. So now let's assume that we have a hashtag, we have data arrays, and then we come here. Our array 1, here, let's create array 1. In data array, you use the function called array. The first argument is your data. You give it So let's say I have from 1, I have a data set of 1 up to 30. That's my data part. The second part is supposed to be my rows, my columns, and the number of arrays, the number of matrices I want them to appear. This data set, this kind of data is useful when you are dealing with multiple departments or when you are dealing with different sets of people. So each of them will form a matrix. Another one will form a matrix. So I have a data point from 1 up to 30, and I want to create an array. The easiest to do is, after you have had your data part, the second part you use a vector to create it. So you use your C into bracket, then you indicate how many rows do you want. I want 5 rows. I want I want 6 rows. I want 5 columns. And how many times do you want the array to appear? So I want them to appear 4 times. That's all. That's all about it. So if I run this array and then I come to print it, you see that we go to, let me fold this up and you see that we have 1, 2, 3, 4, 5. You get it? 1, 2, 3, and then 4. So let's say the first is department 1, department 2, department 3, and department 4. That's where we actually do arrays. And I can tell you that the matrices that we all created, we can turn all of them to arrays. We can turn each of them. You can just copy them and come. Instead of the n row, the n what and what, just coil everything and come and after the data. Now, let me use one of them and then you see how the whole thing works. So let me use one of my. So I'm going to come here. This was my matrix. It was matrix. So it to an array. So I'm going to use that one and say that's array 2. So that's going to be my array. So you have to change. So it's going to be an array. So from the sample all the way to F, that one is the data. There's nothing you can do about it. But now after the comma, all the way up to F, you don't need it. All you need to put there is a vector. So you put a vector of C, enter in brackets, and you have, and you know the data points are 30. You are sampling 30 from 50. So they are 30. So you have the first value is always the rows, followed by columns, and followed by how many times do you want the array to appear. That one is your choice. So here I choose 4. So that when I finish, you will have them 1, 2, 3. Now, the last, for instance, that will be my. I have array. Just say the. Always don't forget the function. That's what array uses to know what kind of data that you want to. So in this case, I am going to create. I want to create an array of all of us here. All right. I'm going to use our names, but remember somewhere we've already created a vector of our names. I was having it as row names. It doesn't really matter. We are just looking for the variable. So once the variable is already there, how many did I create? I have 1, 2, 3, 4, 5, 6. 6 times 5 will give me 30. Right? So I'll come here and the data part, I'm just going to say repeat. You see, I bring the repeat function and bring the name of the variable I've already created, which is what? Row names. I'm going to come there and say row names, which was there. I'm repeating that particular variable. I'm repeating how many times? 5, because there were 6. So I have finished with the data parts, right? The data part has been finished. So what is now left is for me to indicate my. Is somebody talking?
No,
Okay.
please.
So okay. So I have my C. Then I now just indicate. I have my 6. Then I have my 5, and I have my 4. When I do that, I just come and then I run it, and it runs properly. Then when I print it, you see that it's going to be those of us here, our names repeatedly. Can we all see that? It's actually that simple. Is anybody getting confused? Let me know. Now, that is how we are able to create array. The array creation, that one is very simple. Very, very, very simple. Now, if you want to, give names, dimension names, and then column names, row names, and the matrix names, then you can also do that. So I will do this place and call it naming. This place you are going to be naming your arrays here. So how do we do that? I'm just going to copy any of them that I have done on top here. All of them I have done on top here. I'm going to copy them, come and repeat them down here, and then because I want to keep the top one, I will change the variable names. I'll just add 1 here, come and add 2 there, come and add 3 here. Okay, so that's, but any other thing will remain. So now if I want to add names to it, you would have already created the name, the column names, the row names, and then the matrix names. And that's why when we were creating the vectors for the names, I asked you to create a vector called max names. Now, when you now come to the array, after you have finished the data parts, you have finished the syntax for how many rows, columns, and how many times do you want them to appear. The next thing to do is to say comma and say dimension names, dim names. It should come, and you always use list function to be able to name. So you bring your lists. The list function simply will open. Then you know that you are dealing with rows first, so you bring the variable that contains the row names. And so I call mine row names. It comes properly. Then followed by columns. I call mine was called column name. I didn't add s to it. And then you now bring the last one, which is the matrix names, because you want each department to have a name. So I call mine max, it was max name or something. I've forgotten of how I named it. MX num. Call name MX num. Okay. Where am I? So it was okay. It was this one. Yeah. So now when you do this and you run it, it runs. Now when you bring the array, all the array will have. They will now all have. So you can see if I fold it up, you will see that we now have the row names, the column names, and we also have every department having department names. So we have department 1, department 2, department 3, and so in department 1 you can see the names of the people there, and then their age, their weight, and whatsoever. You come to department 4, you can also see the same thing. You go to whatsoever, and then that's how we are able to create different departments with different names and with their height and their weight and whatsoever. I hope you guys are not. Any question? Let me check if everybody is inside.
Wow.
Eh?
It's interesting.
It looks simple, right? It looks simple. Come again. You say?
I'm tired.
You are tired?
Yeah.
Okay, then I think we should close from here. I will copy I'll copy everything and send it to you like I do often. And then for the video there is extremely too long. You can't watch it. Maybe I'll just go and cut it into two, and then I'll cut into like three on YouTube, and then post them separately. It's too long. All the time that I was having all those problems, YouTube was just running.
Oh,
It,
okay.
even though, yeah, it was running. It was running blank. It wasn't recording anything, but it was just running. So now this is how we are able to do arrays. Now I beg you, I'm not going to show you a small example, just 1 minute. So Paulina, just pay attention for only 1 minute. Just 1 minute. I'm not going to take your time. Subsetting arrays. Array subsetting is a little bit, so you bring the array name. So here I have array 3. No, I was having, okay, no. So I have, let's say, my array 1, which is there. So when you bring the array name, you use the square bracket like this. But unlike the others, this one you have 3 comma. The first one is the row, the second is the column, and the third one is the specific array or the specific matrix where you want to pick the data from. So if I put here 1, and I put here, let's say 2, and I put this place 3, I am saying that I'm looking for one value which is found at the intersection of row 1, column 2 in matrix 3. So in matrix 3, let's come to matrix 3 and look at something. Our matrix 3, this was actually okay. What is it? I've not printed matrix 3, so I wanted to show you before we print it, but it's actually 7. So let's print only the matrix and you see something. This was matrix 3. So matrix 3, look at row 1, column 2. You can see that it's actually 7. And that's how it is. So if anytime you want to do any mathematical operation, you want to add and then subtract, use this strategy. Here, you could have copied this. I could copy this and just repeat them, change them in different ways. If you come and do like this, and I come here, I put here 1:3, and then I leave only this. I am only saying that I want row 1 up to row 3 of column 2 alone in matrix 3. So if I run this, it should be able to print the 3 values for me. I tell you, anytime you want to write data science exams online, they can bully you with this thing a lot. I'm telling you, they bully you with this. It's a little bit confusing, but it's not confusing at all. So what about if we didn't want to print, we wanted to leave some out? Don't forget the negatives. If I negate, if I say from -1 up to -3 of column 2, and then this, I am simply saying that I want to print all the rows of column 2 except from row 3 up to row 1 up to row 3 in matrix 3. That's what I'm saying. So if it will print it everything, but it will leave these first 3 rows out, and that's what it is. And so when you go to matrix 3, you can actually see that this is matrix 3. So you will actually see that you were leaving row 1 up to row 3 of column 2. This is your column 2. This is your column 2, and you are leaving row 1, row 2, row 3. So you are left with 10, 11, and then 12. So you see that when you fold up, you can see we have 10, 11, and 12 around here. Ladies and gentlemen, they say that when the handshake goes beyond the elbow, is insignificant. Tired, you'll be wasting your time. So tomorrow when we meet, I'll just take some 10 minutes to revise arrays, and then we'll go to something else. Any question?
Thank you.
Any question? If there's no question, then
Thank you.
I'll leave it here, and I'll say thank you, all of you, for enduring today my problems. My laptop.
Yeah,
my
thank you.
internet.
Thank you very much.
Thank you very much.
You're welcome. I wish have a blessed evening.
Thank you.
Enjoy your sleep.
Enjoy your sleep.
Please upload the video
Please
so that we
upload
could
the
get it.
video.
Yeah. The video is already on my YouTube channel. So
Please, do you have any guests
Do you have
tonight?
any guests tonight?
no, do you have one for me?
Then I'll come.
I
can greet
the people for you.
Hey, what is it? This my chicken story has gone foul. Okay. What is it? Thank you very much. I will see you people tomorrow. Bye bye.